Alright guys, brace yourself. We're going to do isotopes. Yeah, that's right. So, I'm going to give you 3 different sample problems of what an isotope problem may look like for an exam. I know I just did a video where we kind of filled in a chart, but for chapter 3, let's just do some practice here. So, this first practice, or this first setup is the setup we're used to for an isotope representation, but you see how it has the chemical symbol X. That's no good, right, because that's not an element. Xe, xenon, is an element, but X by itself isn't. So how can I tell what this element is? So let's look at the periodic table, and I look for number 14. Why? Because number 14 is the number of protons, so that's the atomic number, so it's Si. So I can rewrite this symbol actually as 2914 Si, right? So this is really the symbol I'm working with. So for each of these, we're going to identify the following. We're going to do number of P, number of N, mass number, and number of electrons. So for this first one, number of protons is pretty easy, right? Because that's just the atomic number. So it's always going to be this number down here. So atomic number is 14, so that means that we have 14 protons. And the mass number is pretty easy because they give us the mass number. It's the number that's up here to this top left, right? So this is atomic number, which is also the number of protons. And this is the mass number, which is also proton plus neutron, right? Why do I ignore the number of electrons, guys? Is it because electrons don't have any mass? No, electrons have mass, it's just minuscule. If you remember, it's like almost a 2,000th of the mass that protons and neutrons have. Another thing that's worthy of note is that we're assuming that the mass of protons and neutrons are about the same. So that's also worthy of note here. So I'm just going to write mass of P is approximately equal to mass of N. That's something that you should note. Now, is it a little different? I'm telling you, it's so minuscule that it won't matter. So assume that every proton weighs the same as one neutron. And that assume that electrons essentially have no mass because it is minuscule. We can ignore it. So how many, what's the mass number for silicon? In this case, for this isotope, its mass number is 29. And its number of neutrons. So if mass is protons plus neutrons, and I know protons and I know the mass, I do 29 minus 14, and what's that number? 15. So I have 15 neutrons for this situation. Number of electrons. Well, if it doesn't have a charge, which it doesn't, it's not a cation, you would have the same number of electrons as you do protons. Because remember, electrons and protons both carry a equal amount of charge. Positive charge, negative charge. Another question that you may get asked in the homework is the nucleus, right? What lives in the nucleus? Just the protons and neutrons. So what's the overall charge of the nucleus? It's a plus 14. The charge of the nucleus is plus 14. Do neutrons carry any charge? No, the hint is in their name because it's neutral. So protons are the only ones that carry any charge. So the total charge of the nucleus is a plus 14. So we can even write that. Plus 14 nucleus charge. Woo, I'm running out of room already, huh? You can think about it that way. Of course, the overall isotope is neutral because we have 14 electrons to go along with it. So what if they write it out as tellurium-129? Well, that doesn't help me a whole lot. Actually, it does. Let's go ahead and construct this format, right? So you look up tellurium on the periodic table, and he is Te. He's right here. Remember, my periodic tables will have the names spelled out as well. So I can write the chemical symbol as Te, and 129 refers to the mass number. So 129. And what's my hint? Could it possibly be the atomic number? Absolutely not. We don't even go that high, right? So Te has a number of 52 as its atomic number, so that also means that's the number of protons. So we're getting ahead of ourselves here because it's kind of exciting. So number of neutrons, number of protons, number of electrons, and then I need mass number. All right. So from this, we could very easily identify a couple of these. 52 is the number of protons. So it must also be the number of electrons. The mass number is this given number here at the top left. So 129 for this situation. And then the number of neutrons, if we remember, 129 has to be the total of 52 plus the number of neutrons, so it's just subtraction. So 129 minus 52, I do not do that in my head either. I got 77. Ooh, I'm writing kind of, you guys are following along with me though, I'm very sure. I have confidence in you, but it's 77 neutrons. Perfect. So this is another way that I could write out a isotope. Let's go down to a classic example. This is another way it could be represented. Right, so I'm giving you the elemental symbol, CO. So cobalt, you can find him on the periodic table. He should be element number 27. And for this isotope, he has a mass number of 58. So we have just identified that protons, we have 27. For mass number, we have 58. How many electrons? 27, right? Because we need to have just as many positives to balance out the negatives to be neutral. Now the number of neutrons is the only one we really have to calculate, and that's going to be mass number minus number of protons. So it's going to be 58 minus 27. Ooh, I think I can do that one in my head. I think that's 31. Yeah. So that's 31 neutrons. So this is just a good practice for you in how to determine number of protons, neutrons, and electrons, and mass number from any kind of given isotope symbol or, verbiage. Well, good luck, guys.